Hello everyone, my name is Ishan and I am the Science and Tech faculty at UPSCprep.com. So today we are bringing to you the complete coverage for the Science and Tech current affairs. A lot of people say that you need to look at a lot of booklets for the Science and Tech current affairs, especially for the past 1.5 years or 2 years. But it becomes very difficult for you. It becomes very difficult for the understanding. It becomes, a lot of work to do. So we are trying to simplify some of that work for you and bringing the most important topics that you can look at for this year's prelims to be held on 16th of June, as you all know. I have divided these these current affairs into different sections. Now some of you might say that okay, there's this particular section or that particular section, but for the purpose of this particular session, let me tell you how I'm going to proceed. So first we are going to start with space technology, yes, and then we are going to move towards biotechnology. Thereafter we'll look at things related to AI, IT, computers and robotics. That's all clubbed together. And then after that we'll look at briefly at the nuclear power, and lastly we'll look at the Nobel prizes. So that's going to be the agenda, and I'll tell you what all topics we are going to discuss for each of these sections. So yes, let's start, and I hope this session is useful for you. Anyway, it's going to be helpful even for mains. Don't think that prelims and mains are two separate things. Most of the times it's the concept that's important, right? So today we are looking at the current affairs from the view of concepts also, right? It's not just the information. Okay, so let's start. All right, so let's start with the space technology section, and you can see a list of topics over here, right? And these are the most important missions or other kinds of terms or news related to space tech, which was there in the news for the last 1 year or 1.5 years. And these are topics, some of these topics are going to be important for the future, like Deepfakes. Others will keep coming on in news, like Gaganyaan, right? And some of these, like XPoSat, Aditya L1, you might know. NISAR also is going to come up. Right, and then there is some research regarding black holes, dark matter that has been done, and these are some terms that have come up in news: fast radio bursts, gamma ray bursts, blazars. We'll understand what are these. And then there are some projects like LIGO-India Project and UPSC project. These are also some important topics. So we'll understand what are these one by one, and we'll also understand how are the questions going to be asked from such kinds of topics. Okay, so let's move forward and let's start with the first topic, that is the Gaganyaan. So before going into Gaganyaan, let's look at the launch vehicles first. Let's briefly understand that these are different stages of launch vehicles of ISRO, right? So back in the day, we started with the small, small vehicles like SLV and ASLV, and then we moved on to things like PSLV. So PSLV XL was the biggest model of the polar satellite launch vehicle, or the PSLV models, and it is considered as the workhorse of ISRO. Is the most successful of all the launch vehicles till date, because it has 50-60 missions to its credit. Then there was the GSLV Mark II, which was not very successful, maybe 5 or 6 missions. They for that they used GSLV Mark II. It had some limitations, but those limitations were overcome in the Mark III versions, and this is the latest, this is the most powerful version, most powerful launch vehicle of ISRO. Right, you can see the carrying capacity also is much more than the other ones, the previous versions of launch vehicles. So it is the most powerful launch vehicles, and this was used for your Chandrayaan 3 mission as well, right? So mostly you use it for big missions like these, and for Gaganyaan also you need a big vehicle, right? So essentially what you are going to do is use your GSLV Mark III, which is also called as, now they have renamed it as launch vehicle Mark III, right? So this is the name for GSLV Mark III. They had renamed it. But for Gaganyaan, you will hear the terms HRLV. So what is HR over here? HR means human rated. Human rated means now what they have done is they have rechristened this vehicle or modified this vehicle to suit the needs of human space flight, which means that it will have some components which are useful for human missions, human space missions. Now, you sending things to Chandrayaan 3, there is no human over there. So obviously, if you are attaching some new things over here, you will call it something new, because it's a new system now. So you call it as a human rated launch vehicle, or HRLV Mark III. right? So you look at this vehicle, this part over here, you would know first stage is solid, second is liquid, and third is cryogenic. What is this? This is your GSLV Mark III, right? This is the GSLV Mark III. Then you have attached the orbital module to it. What is this orbital module? Inside this orbital module you have crew module, and you also have the service module. So inside the crew module you have the astronauts, or in India they might be called as Vyomnauts or Gaganyaan. We'll see in the news like what is the term attached to them. For now let me call them astronauts. So in the crew module you will have the humans, or the crew members or the astronauts over here, and the service module you will have the propulsion systems, right? Propulsion means what is used to propel the engine and everything else. So these systems will be there in the service module. Then there will be a crew escape system, which means in case of any emergency, in case there is some problem in the launch vehicle, in case there is some difficulty that the crew members are facing. So in this crew escape system, what will happen is that if the crew members or the astronauts, they want to abort their mission, they can simply go to this part of the vehicle, and then it will take them back safely to Earth, right? So this is made for some kind of emergencies or some kind of abort operations that need to be performed. So recently some abort tests were also conducted, right? Those were in news, right? So what are the features of the Gaganyaan mission? You can see that first is the demonstration of human spaceflight capability, right? It is the first such mission for India. You know that US, Russia and China have already done these kind of missions. So India is going to be the fourth such country which is going to demonstrate this human spaceflight capability, right? So there will be three actually there is the 4 crew members now. You can see the names in news. They will be carried up to the orbit of 400 kilometers for 3 days mission, and they will be brought back safely to Earth by landing in the Indian sea water, right? So it will use LVM3, recasted as HLVM3. We have already discussed this. And it also might develop a semi-cryogenic engine. So what happens in a semi-cryogenic engine is, for that you must know what is a cryogenic engine. In a cryogenic engine, what you do is you have a liquid hydrogen and liquid oxygen, right, at very low temperatures, right? So they are there at very low temperatures. That is why this is called a cryogenic engine, right? So in semi-cryogenic, instead of liquid hydrogen, you have kerosene, right? So it's said to be more efficient, right? So that is why they might develop a semi-cryogenic engine specifically for this Gaganyaan mission, right? So you also need to keep looking up for this kind of news item in the coming months, right? So you can see the trajectory of this mission now. It's written 5 to 7 days. This was the plan earlier. Now the plan is only to spend 3 days in the space. It's very simple. You can see that. First, this flight will take off from Sriharikota. It will take 16 minutes to reach the low Earth orbit, right? So 400 kilometers. Then it will be, you can see the orbital module. You know what is there in the orbital module. The crew members, they will be deployed, and they will, they will spend 3 days over there in space, and then they will be after those 3 days they will perform a deboost landing, where the crew members will separate from the service modules, and this crew module will, you can see it is coming down. It usually comes down. You must have seen those videos in movies, how these things come down in the ocean waters. So this is how they will come down, splash down at Arabian Sea of the coast of Gujarat, right? So you can see that launch date has been pushed earlier. It was to 2022, but definitely because of COVID and because of other reasons, it's been pushed now. So we are expecting maybe at the end of this year or next year, you might see Gaganyaan mission taking shape, right? So that's all about Gaganyaan, which was there in news. Let's move on to the next topic. So before that, you can see that these are 4 members which have been selected, and they are being trained in the there is a star center in Russia which is close to Moscow. So over there, even Rakesh Sharma was trained over there. So they are being trained in that in that institute, and they'll be going through a very rigorous process of training. And this was the mission, recently why this was in news was that the TV-D1 mission was the abort mission that was being tested, right? So it was successful. So obviously these kind of tests will keep on happening. You need to keep an eye on these news items, right? Okay, so let's come to XPoSat. XPoSat is India's first and world's second X-ray polarimeter satellite, right? So why world second? Because NASA has already launched something similar. It was called IXPE, Imaging X-ray Polarimetry Explorer. So that was a couple of years ago, a bit more than that, right? But it was also going to do the same thing, measure X-ray polarimetry measurements from the astronomical celestial sources like like galaxies, like stars, like nebula, different kinds of objects in the universe. So what happens is, what happens in the universe is that all these objects, these galaxies or stars, they emit X-rays, right? X-rays, right? So X-ray is a form of electromagnetic radiation, right? So what you want to do is you want to measure the polarization of these X-rays, right? So what will that tell you? What it will tell you something about these objects, because if you are measuring these parameters, it can tell you something about from where are these coming from, what is the intensity of it, what was the earlier intensity of it. So it can tell you a huge amount of answers to the questions that we right now know nothing about. So for that, for all this, first you need to understand what is polarization. So in any kind of electromagnetic radiation, what happens is that usually you have these kind of electric and magnetic fields in all the directions, right? All kinds of directions. But when you pass it through something like a Polaroid or some kind of instrument that can polarize this light, what happens after polarization is that your oscillations are in one single direction, in one plane, right? So they are in a single plane. So if I put a wall around this, all of these arrows will be on the wall, right? No arrow will be coming out of the wall. So that is the meaning of polarization, right? So if these are X-rays, right, then you want to study the polarized version of these X-rays. What is the degree of this polarization? What is the direction of this polarization, right? So for that you have put these payloads like POLX and XPECT, right? So what is POLX doing? It is measuring the polarimetry parameters like the degree and direction of X-ray photons which are coming from these. So around 50 sources have been identified from there. So they will be measuring polarization of these X-ray photons from those kind of sources, right? So mission life you can see is 5 years, right? And POLX is the primary payload, and then XPECT is the secondary payload, which is going to measure the spectroscopic information and timing of these soft means weak, right? You can understand this as weak X-rays. So it is going to measure the spectroscopic information. Spectroscopic, you all must be knowing about spectroscopy. It comes up in a lot of payloads. It is used to measure the physical and chemical composition of astronomical objects, right? So this is basically what is all about XPoSat. It has two payloads, so POLX and XPECT, and it has already been launched. It is already doing its work. There are some observations that you come across in news already. There have been some observations which they have, which ISRO has seen using this instrument. So a lot more is going to come, and the main objective of this satellite is to understand the mysteries of the universe, because there's a lot of mystery attached to galaxies and black holes and nebulas and all different kinds of stars, right? So you might be able to get some of the answers to many of the questions that you have, right? All right. So the orbit is it is the LEO orbit, which means it is written 500 to 700 kilometers over here, but they have put it in the orbit around 650 kilometers, right? Inclination is around 6 degrees. You don't need to know all this deep information, but just remember it is a part of LEO. Even though it is kind of in a space observatory, it is still in the low Earth orbit, right? There was another observatory called AstroSat, which was launched around 7-8 years ago, more than that, in 2015 around, right? So this is it was also launched by ISRO as a part of some kind of astronomical observatory, some kind of observation mission. And so what is the other observatory? It is Aditya L1, right? So these are types of observatories, because it is going to observe the sun, right? So all these are types of observatories. XPoSat is also one of them. So let's come to NISAR. Now NISAR is a collaboration between NASA and ISRO. It is a collaboration between NASA and ISRO. The full form is NASA ISRO Synthetic Aperture Radar, SAR stands for synthetic aperture radar. Understand it like a camera. Understand it's a kind of a camera, right? So it is scheduled to be launched. Actually it was scheduled much earlier, but it has been postponed again and again, and we are expecting this to be launched in this month maybe, or let us see, right? Because it keeps on getting postponed. So the schedule is set to be March of the 2024. Let's see when it is launched. So whenever it is launched, obviously you will get to know a lot more about it. So let me tell you in advance that the orbit that they're going to place it is in sun synchronous polar orbit. Now why is it placed in this orbit is that it's kind of a camera, right? And if I tell you the objective for this, objective is to map the Earth in very high resolution. It is a joint project to observe the Earth in never before resolution, which means that they are going to capture high quality images of all kinds of things, right? So why are they doing this? Because they'll get to know in depth about things like volcanoes, earthquakes, cyclones. What are their impacts? How is it impacting the topography? Where is the damage the most? And also predict them in the future and make some kind of policies regarding climate change, regarding ecosystem management, right? So it will help in all these things. Why? Because when you are in sun synchronous orbit, you can map the Earth every 12 days, right? Every 12 days it will be able to map Earth. It will be providing this information. So understand, like if this is an area, 12 days later you get new image of this area, then you will create a lot of images like these, and you can find some pattern out of these, and then you can say, okay, there was the forest over here, now this forest has been reduced to this, now some water has come in, and now this water has dried up. So you'll keep on monitoring these kind of images, and then you will find some kind of solutions to climate change, or you will predict some patterns, understand some patterns. So that is why it is mapping Earth in never before resolution, and it is using dual frequency for this, dual frequency bands, right? So it's using two bands. Whenever I say these bands, understand it like there is a particular frequency and a particular wavelength attached to any band, right? So here we are using S and L bands. So L is being provided by NASA and the S band is being provided by ISRO. You can remember, like S is there in ISRO, so S band is being provided by ISRO. Alright, so this NISAR is utilizing this synthetic aperture radar technology, and which I have already told you. Understand it like a high resolution camera which is providing high resolution images of the Earth's surface. It is a dual frequency radar system enabling day and night and all weather imaging capabilities, which means that if there is some kind of rainfall, cyclone, anything that is happening, this is not going to affect the functioning of NISAR, right? Then global coverage with repeat observations will track changes over time, like I already told you. Okay, so the date over here is wrong. Obviously, as I told you, it was scheduled to be launched much earlier, but now it will be launched this year, and we'll read more about it when it comes in the news. So let's come to the Aditya L1 mission now, and it is a very famous mission. Most of you will know about it. It was a lot, and it was there in news for a long period of time. So it is a satellite which is dedicated to a comprehensive study of Sun. You all know, from the L1 orbit. Now, if you don't know what is an L1 orbit or Lagrange points, let me briefly explain it to you. If you consider Sun and Earth as as a two-body problem, which means there is nothing around, there is nothing else around. These are two bodies. Then there are certain points where if you place an object, it will remain in that position, constantly in relation to the two bodies. What I mean by that is, if I explain it to you diagrammatically, if Earth tomorrow comes to this point, then this L1 point will also shift. If Earth goes to this point, then L1 point will be here. If Earth goes over here, L1 point will be here. So this L1 point is not stationary, it is also moving along with the two objects. Okay, so please remember that. Similarly, these other points L2, L3, L4, L5 you see in the diagram, they will also keep moving along with the position of Sun and Earth, right? But they will remain constant, you can see. So if you send an object to these points, it is going to be very cost efficient for you because you don't have to spend on fuel. You place that object in that point, at that point, and it's always going to remain in that point, forever. In relation to the two bodies like Sun and Earth, it will always remain in that in that point between them, or away from them, or anywhere else. Right? In L1, we can say that it is going to be there in between them for all times to come. Right? So that is why you are sending it to this L1 point. First reason is that it's going to be cost efficient. Second reason is that you can study the Sun very closely from here. You can see that the other points are not very, not very suitable. L3, L4, and L5 are very far. Now L2 is on the other side of Earth. So Earth can create a shadow, so that it's very difficult for you to look at the Sun directly from this point. So L1 is the most suitable point. That is why we have sent our Aditya L1 spacecraft to this L1 point. Okay. And what we have done is, you must be knowing about orbit maneuvering. So we always do this maneuvering, this slingshot strategy. We always transfer these orbits from the lower orbits to higher orbits. We keep on going, and then we finally exit from the Earth's sphere of influence, and then we go directly to the point L1. So what we have done is, after this, what actually happens is that this Aditya L1 does not go, and it's not a point in the universe where the spacecraft will go and say, okay, I'll stay at this point. No, it does not happen. It will stay in the orbit around that point. Okay, it will stay in the orbit around that point. So you can see that there is a small circle here. So it will keep rotating in these circles. Okay, and this is called as the halo orbit, okay, because it creates kind of a halo around the L1 point. If this is the L1 point, so there is a halo which is created around this point. Okay, where the Aditya L1 will be revolving forever. This halo orbit is where we have sent our spacecraft, right, to study the Sun. And this spacecraft has 7 distinct payloads. Each has different functions, measuring the, looking at the Sun in UV light, and all the other kinds of, measuring solar winds, different kinds of plasma analyzers. All kinds of things are there to study the Sun, right? And all have been developed indigenously, which means made in India. And if you look at Aditya L1, it will stay approximately 1.5 million kilometers away from Earth. So not very far away from Earth. It's very close to Earth. Right. Usually, if you think about it, most of the times you might be misled by some kind of articles that it's how will it not burn? No, obviously, because Sun is over here and your Aditya L1 is here, Earth is over here. It's only 1% of the distance that the Aditya L1 is covered. There's 99% of the distance still left to reach Sun. So obviously it will not burn, but yes, it will be observing Sun from this close quarters, which is still very close. Okay, so then it will give you some information. Now the question arises as to why are you studying Sun? What is the reason? Why make so much effort, make such a satellite, and then send it to outer space into Sun, and understand what is happening. So the reason lies in this diagram. You can see that there are different phenomena that are associated with Sun: solar flares, solar winds, coronal mass ejections, geomagnetic storms, and something related to this also. I'll come to this in a short while. But main reason is that these solar flares, winds, and coronal mass ejections, especially these coronal mass ejections and solar winds, they have the potential to disrupt the communication systems, your satellites, and your power grids, and all the different kinds of electric and magnetic systems that you might have had around Earth, right? So usually also they keep on disturbing, but what happens is that Earth has a strong magnetic field around it. So the Earth protects us. Earth protects us from these kind of coronal mass ejections or solar winds, right? But if tomorrow there is a solar maximum, which is expected in a few years, if it's there and it disrupts, it reaches Earth and it disrupts all your satellites, your things, talking about sending so many satellites into outer space, then what happens to your communication systems? It can create a major havoc. So that is why you need to understand these things, and you need to be able to predict these things, so you can make some adjustments back on the planet Earth, right? So that you can save some precious resources that you have. Right? So that is why it is important to understand, and that is why you are sending these spacecrafts to study these solar winds, solar flares, coronal mass ejections, geomagnetic storms, right? So this will give you some kind of idea. Now, if you are not able to understand what are these terms, let me briefly go over these terms so that you can understand. So starting with solar flares are, they are localized bursts. What happens is that there are, some magnetic field will be coming like this, and then another will be coming like this, right, and then they'll interact with each other, and there'll be a massive explosion kind of a thing, and that is called as a solar flare. They travel at the speed of light, so you can reach Earth in 8 minutes. Sunlight reaches Earth in 8 minutes. Similarly, solar flares also can reach Earth in around 8 minutes. So they appear as a bright spot on Earth that fades from minutes to hours. Obviously, they will appear as a bright spot because some kind of magnetic field mingling together and creating an explosion, right? Actually, those are magnetic storms, right? So they mingle together and create some kind of an explosion, right? So here again, then you have coronal mass ejection. Now they are these again they are these eruptions, but they are these giant clouds of particles which are hurled into outer space, right? And these ejections, they do not travel at the speed of light. They can take 2 to 3 days to reach Earth, right? So now you understand why prediction can help us, right? Because they take some time to travel to reach Earth. So if we are able to understand, okay, today there is some kind of a massive coronal mass ejection which can tomorrow hamper systems on Earth, then we have some time window to help prevent such kind of disasters, right? So it is a large eruption of electrically charged gas and magnetic fields from sun that is accelerated into space by the solar wind, right? So what is the solar wind? Again, solar wind is just like a wind, but it is a wind of electrons, protons and helium nuclei and magnetic fields which are coming from the sun, right? So these kind of things we want to study. Then what is the geomagnetic storm? Again, it is a geomagnetic means disturbance in the Earth's magnetic field. Geo means Earth, magnetic means magnetic field. So major disturbance in the Earth's magnetic field caused by a large influx of energy from the solar wind is called as a geomagnetic storm, right? So largest storms happen when a coronal mass ejection reaches Earth, right? So already don't think like we have escaped these kind of events. Some 200 years ago, some event known by the name, if I am recalling it correctly, it was the Carrington event. You should read about it, which happened when all the telegraph lines stopped. There was a current flowing through every instrument, and the telegraph lines also stopped working, or something like that happened. Please read about it. Okay, so if something like that happens today, it will be kind of a disaster, right? Even a few years ago, there was some news in Canada, power grids stopped working. So there were blackouts, in parts of Canada. So such kinds of things can happen. So it is something that we need to be careful about, right? So that is why we are studying this. Okay, and yes, and one more reason to study this is that you don't know about the behavior of the layers of the sun. You can see, if I point it out to you, you can see that these inner layers, temperature is very high. In the inner layers, obviously there is nuclear fusion, temperature is going to be high, right? But in the outer layers, you can see temperature drops dramatically. Temperature is not as much, only just a mere, it's definitely very, very hot, you cannot survive over there, but compare it to these inner layers and you see a drastic change, right? So you don't know the reason for this. That is why you need to study this. There is no explanation as yet. There are different theories, but no one knows. So we also want to study these kind of different mysteries, right? Now, one more thing that I can just briefly mention that usually what happens is that when these electric and magnetic fields come from the sun and they interact with the Earth's magnetic field, usually there are these visuals that are created in the north and south poles, which are called as auroras. They are beautiful. And if you haven't yet looked at a picture of them, I'd suggest you to go and have a look. They are beautiful sights in the night sky, right? Colorful auroras. So you must look at a picture of them. Okay, so now we come to LIGO-India Project or LIGO-India Project, right? So the full form for this is Laser Interferometer Gravitational Wave Observatory, right? So if you don't understand the meaning in deep detail, just be sufficient for you. It will be sufficient for you to know that this is a project which is going to understand or detect gravitational waves in the universe. Now, what are gravitational waves? Einstein's general theory of relativity predicts that that mass will disrupt space-time fabric. Okay, so what is space-time fabric? In the universe, there's space and time. They together they form the space-time fabric. And imagine it like a sheet like this, right? So if you drop a heavy object like a black hole over here and a black hole from this side also, right? If they two come together and they will try to eat up each other, what will happen is that there will be some ripples that will be created in this space time. Like there will be some ripples, like just like in the water, if you throw a stone in the pond, there are some ripples that are created, right? So these ripples essentially are what are gravitational waves. Now it's not easy to detect them because only massive objects can create these gravitational waves in the sense that they can be detected, right? Otherwise it's not easy to detect them, right? So this project is dedicated to that. This observatory is dedicated to understanding where are these gravitational waves occurring, how to detect them. And this is actually a collaboration from India. There's Department of Atomic Energy and Department of Science and Technology, and along with in USA there's Caltech is California Institute of Technology, and then MIT. Both of them they have a LIGO observatory. So they are collaborating with India to make this this observatory in India. So in Hingoli district in Maharashtra, they are it is a project of 2600 crore. So they are building it over there. You can see the pictures. So it is a planned advanced gravitational wave observatory, which is part of the worldwide network. Actually, a lot of countries are together. They are collaborating to build these observatories in different parts of the world, right? So after that, they'll probably build one in Japan also. So at different parts in different locations of the earth, they are trying to build it, and together they will collate the data, and then they will understand how the gravitational waves are created in the universe, and probably detect them and understand more about them, right? Then you come to OSIRIS-REx mission. Okay, so OSIRIS-REx mission, recently it was in news. The reason was that it brought back samples from an asteroid called Bennu. Okay, so Bennu asteroid is the place where this OSIRIS-REx mission was sent, right? And it actually brought back samples from this asteroid. Now, why did we go to this asteroid? Because this asteroid is said to be coming from the dawn of the solar system, right? So it may be from the beginning of the solar system. This asteroid has been there. So it might harbor some of the facts around the creation of life, or it might have some answers to the creation of the solar system. So it might have something inside it, which the scientists will now study, because they have the samples. Okay, so what happened in this course of during the course of this mission was that this spacecraft was sent on 2016 September 8. It was sent from NASA. And 2 years later, it arrived near the asteroid. So, okay, then it mapped the asteroid to find a safe place to land. For a few seconds, it touched, for 5 to 10 seconds, it touched the ground of the asteroid and collected samples from there. It dug a hole deep into it and collected some samples from there. Then it head back to Earth in March of 2021, and in September 2023, it arrived in the Utah desert. Already it has arrived, already the samples have been collected, but there is a catch over here. So what they actually did was, because there was some leftover fuel from here, so they let the spacecraft deliver these samples of Bennu to the US, but they let the spacecraft go to another asteroid because the fuel was left over. So it was sent to another asteroid, Apophis, which we want to study, right? I'll tell you the reason in a bit. But let's come back to Bennu for a while. So they have collected these samples, and now these samples are being sent for the study. No need to look at the payloads or equipments in that detail, but you need to understand what is this mission about and what is this Bennu asteroid, right? Features of this Bennu asteroid, you can look at it from here, right? And then you understand about Apophis, because Apophis is the new asteroid that this is this OSIRIS-REx is going to look at. And now it is called, instead of OSIRIS-REx, it is now called OSIRIS-APEX. The mission is now renamed as OSIRIS-APEX because it is now studying Apophis asteroid. Now Apophis is some asteroid that is going to come very close to Earth several times on these dates, you can see. So actually the thing is that it will pass very close to Earth, but the problem will be there if it actually collides with Earth. So it can actually lead to a lot of damage if it collides with a place which is densely populated, right? Because it is going to leave a crater which is going to be thousands of miles wide, right? So it can lead some not thousands of miles, I'm sorry, it can lead to a crater which is a few miles wide, but that is going to be sufficient for you, to cause a harmful impact, right? So because this Apophis is going to be very close to Earth and it can create some harmful impact, that is why we want to understand how we can prevent such disasters. So as NASA wants to know how to divert the course of this asteroid. If it's coming close to Earth, okay, if it's coming close to Earth, maybe we can send some kind of spacecraft which can divert the route of this asteroid. It can go away from Earth, right? That is what we want to study. So that is why this OSIRIS mission has been sent again to another asteroid called Apophis, right? So you can see that there are 10 possible dates that could this asteroid could hit the Earth. On each date, asteroid is expected to make a close pass over planet, and a slight change in its trajectory could spell disaster, right? So there are some features over here that you can look at for your own understanding, right? So you just need to keep a tab on this. Actually, it will reach much. This Apophis, it will reach probably, it will take 4-5 years to reach Apophis. So it is a lot of time, right? But you need to know why it is going to Apophis and what is Bennu and what is Apophis, right? So in exam they usually ask, they can put questions like Apophis is a type of what? It is a type of an exoplanet, an asteroid, a comet, or something. These kind of options they can give you, right? So then you come to LUPEX. So LUPEX is again, it is a lunar polar, full form says lunar polar exploration mission. So polar, which means South Pole. We are again going to the South Pole to study the South Pole, but this time we are not going alone. We are going along with Japan. Okay, so we are going along with JAXA. This is the name of their agency, Japan's Aerospace Exploration Agency. So ISRO is going to along with JAXA to the South Pole again, and they will be carrying again, there will be a lander and there will be a rover. Just like in Chandrayaan 3, there will again be a lander and a rover, and this is scheduled to be launched next year. We'll see how, whether it is actually launched next year or not, but this is the plan. So this time again they will go, and then what they will do is they will try and find more sources of water, because there are certain regions of moon which are which rarely see sunlight. These are called dark regions of the moon. So over there is a possibility that water can be stored even underground, if not on the surface, but there is a high possibility that water is there in that side of the moon. So they want to study this, they want to find water. Why do you want to find water? Because if you find water, please try to understand that tomorrow if you're going to space, you cannot carry everything from Earth, right? If you're carrying the fuel, if you remember launch vehicles, most of the weight in the launch vehicles is the fuels. And if you're carrying so much of fuel from Earth, it's very difficult to go far away in the space. But if you find water on the surface of the moon, and because water has hydrogen, then hydrogen can be used as a fuel tomorrow for your launch vehicles. So what actually can happen is, from Earth you can go to Mars, and Mars can be like, yes, you can go to Mars, but on the way you can recharge your launch vehicle on the moon using this hydrogen, right? So you can get use that hydrogen as a fuel, and then you can proceed further to Mars. So this is the plan. That is why you are looking for water. It's not like you find water and you can solve the water scarcity in Bengaluru or something. That is not the case. So please understand the motive of all these missions. Why are we going for water? Why are we sending this rover or lander? Right. So there are specific reasons attached whenever they are sending the mission to the moon or Mars or any kind of other place. Okay, so water prospecting is a objective, then demonstrating new surface exploration technologies, obviously, there will be some advancements in the lander and the rover, so they'll demonstrate that technology also. And sustainable exploration, as I said, if you want to sustain the exploration in the polar region of the moon or in the far beyond in the solar system, you need to find water, or you need to find something else, right? So you need to discover something new, right? So the lander will be provided by ISRO, while the JAXA will be providing the rover. This is the plan as of now, and the launch vehicle also will be provided by JAXA. So you keep a tab on this news, right? You keep looking for this in the newspapers, and it will keep coming up, right? So that's all about LUPEX. Then we come to black holes and time dilation. So recently some scientists have demonstrated that black holes have scientists have found that black holes have demonstrated time dilation, again something that Einstein had predicted. So for that, you don't need to go into the findings of the scientists. You don't want to become a scientist, but you definitely want to become a bureaucrat. So you need to know something about what is a black hole, what is time dilation, all these things, right? So I think black hole, most of the people, they get very intrigued by this concept. These are regions of space-time which have immense gravity and where nothing, not even light, can escape. Right. So what happens is, whenever a star dies, usually there is a black hole that is created. Right. So if it is a single massive star, it will create a stellar black hole. Stellar means star. That black hole will be called a stellar black hole. And if the mass of that star is millions to billions of solar masses, millions to billions means much bigger than our sun, millions and billion size bigger than our sun, then those, if they collapse, and they will form a supermassive black hole, and anything in between these will be an intermediate black hole. Okay, so they can come in different sizes. Black holes can come in different sizes, but remember that there are regions where there is very high gravity, there is immense gravity which can pull anything that comes close to it. Right, so you can see this picture of a black hole. This is kind of a black hole, and you can see even light cannot escape from it. Even light is gobbled up by this black hole. So formation occurs when black holes form when massive stars collapse, creating dense objects with strong gravitational pulls. I hope all of you understand that. Right. So why are these crucial? They are crucial for understanding the universe's evolution and galaxy formation. Right, because at the center of every galaxy there is going to be a supermassive black hole. Even at the center of our galaxy there is a black hole. Right. And studying them illuminates fundamental aspects of space, time and gravity, because you can understand more about how space works, how space time works, and how gravity works by looking at these objects in the space. Right. So time dilation actually is an effect which is created because of these black holes, because there is immense gravity, and because of the general theory of relativity, whenever there is a massive object, if you have a very massive object, then you can understand, like, if there is a very massive object, then the time can slow down a bit. Right. So if you are on Jupiter, maybe you will be much younger than if you are on Earth, and if you are on the moon, maybe you are a few milliseconds older than you are on Earth. Right. So mass of the object can affect the time also. So this is why black holes, because they are immensely dense and they have immense gravity, they can also affect the notion of time. So that is why they are associated with time dilation effect. Right. So you can see this is also, you can see there is a supermassive black hole over here. So what I want you to understand from here is the concept of quasar. These are also in exam. What can happen is that they can ask you match the following. On one side they will write quasar, blazar, right, radio galaxy, all these things, and the other side there will be some descriptions which you have to match. Right. In the exam, these questions have been asked, and they can again be asked. So briefly I will tell you about what are quasars, blazars and radio galaxies. There is nothing to worry about this. Yes, these are not complicated terms. Actually, when you look at this galaxies, right? So what happens in a galaxy is there is a supermassive black hole in the middle, and there is an accretion disk. Accretion disk is all the stars and dust particles and everything which is being eaten up by this black hole. And these are objects which emit radiation of all kinds, electromagnetic radiation of all kinds, and that is why they are very bright also, right? But they are spinning very fast, so they can create such some kind of outbursts like this, outbursts like these, right? So if these outbursts, they are perpendicular in relation to the position of Earth, then it is called as a radio galaxy, right? Then it is called as a radio galaxy, right? And if they are staring right at us, this is staring right at us, right, then they will be called as a blazar. And if they are at an angle, like this, right, so then they will be called as a quasar. All right, so it's in the it's from where you are seeing them, right? So it's not like they are different things. It's like from where you are seeing them. If you are seeing right at them, then you are calling them a blazar. If they are perpendicular to your view, then you are calling them a radio galaxy, and if they are at an angle, then you call it as a quasar, right? So over here you will see a quasar, right? Here it will be clearer to you. You can see blazar is, you are looking at these relativistic jets, they are called in technical language. So you are looking at them right into the barrel of the gun. It's like looking right into the barrel of a gun, and then they will be called as blazars, and if they are at an angle, then you will be calling them as quasars, right? So why are we studying blazars and quasars? Because recently Indian Astronomical Observatory has observed the brightening of BL Lacerti, which is a blazar. So in exam they can ask you questions like a BL Lacerti is the type of option A GM crop, option B blazar, option C some new tech name of an app or something like that. They can put 4 options, and then you might wonder what is this, because it's not very clear from the name itself, right? So just remember it is a blazar. Okay, so blazar is, as you all have studied, it is a type of galaxy powered by a massive black hole at its center, and it is right in the view of Earth. The relativistic jet of this galaxy is right in the view of Earth, and they are among the brightest and the most powerful objects in the universe. They are actually the most luminous objects in the universe, because they are, look at them right away. And as I said, these objects, they over here in the accretion disk, they emit radiations of all kinds. They are very, very bright, right? From gamma to from gamma to visible to all kinds of rays they emit. So they are very, very bright, and that is why they are the most luminous objects in the universe, right? So blazars are known for emitting highly energetic particles and radiation, that you all understand. That is the thing in the relativistic jets, right? So let's move on, and let's move on to the next piece of news, that is the dark matter map. Now scientists from different countries, they have created something called a dark matter map. They studied dark matter. You can see the names of countries, different countries which use some kind of telescope, Atacama cosmology telescope, to study dark matter. So what actually happened was, they studied the cosmic microwave background. Now you might be intrigued to know, like, what is this cosmic microwave background? Or some of you might be asking, what is dark matter indeed? Why are we studying about some new kind of matter? So please understand that in the universe, whatever you see, whatever is there in the outer universe, or whatever you see around you, all that visible matter is only 5% of the entire universe. All that visible matter, it's only 5%, right? Then around 25 to 27%, I'll write 25 for the sake of simplicity, it is dark matter, right? It is dark matter, and the rest of 70% is dark energy. So what is this dark matter? This dark matter is actually some invisible matter. It is matter, it has gravity, but it is invisible, right? But because it has gravity, it can create some effect which we can study, right? So when we study the cosmic microwave background is nothing but the old radiations which are coming from the time of Big Bang. You can understand like they are coming from the time of from the initial stages of Big Bang. Those radiations that are coming, when they are when they are affected by this dark matter, they are affected by this dark matter, and then then we get to know that where is the dark matter. That is how you create a map. Okay, so what actually happens is it's kind of a lensing effect. So dark matter is over here, it has gravity. Okay, Earth is over here. So you can say that the background radiations can be coming from objects over here. You can say Earth is over here, and let me redraw this. You can say that some kind of object is creating CMBs, cosmic microwave background radiations from there. Okay, then what happens is that there is some kind of lensing effect that happens. Okay, so light, because you are observing from Earth, you cannot see because there is dark matter over here, so you cannot directly see these old radiations. Then what happens is that when these radiations pass through these this dark matter, because of the gravity, the light bends, okay, and then it reaches Earth. Because this is called as the lensing effect. Okay, I am explaining it in a very simple manner. Actually, this lensing effect is why it happens because of gravity, and it is why we can see some objects which we can otherwise not see. Because of this lensing effect, we can see some objects which are deep into outer space which we otherwise cannot see. Okay, so that is how you detect dark matter and some other kinds of objects in the universe. So this is how you detect. This is how you create a map of dark matter, and they have already created a very detailed map. And this map is it is in line with the prediction of the Einstein's general theory of relativity. Right. So this dark matter, which can't be seen, affects light passing through it due to its gravity. As I told you, think of it like a magnifying glass bending light, revealing hidden structures. Again, as I told you, by tracking this bending in the CMBs, researchers created a map showing where dark matter is. Right. And addressing a major cosmological question, the rate of formation of dark matter lumps over time. Lumps means, if you look at this map, you can say that, okay, so instead of this map, let me draw. So you can understand the dark matter lumps as something like these are lumps. Okay, lumps means they are accumulated in some places. Okay, so they have studied over the rate of formation also of these lumps, and they have they have understood this, and they have found that this is in line with the predictions of the general theory of relativity. Now don't go too much into detail because not aiming to become a scientist, right? That much should be sufficient for you for this topic. Then let's come to, so moving on, now we come to FRBs and GRBs. Now FRBs are fast radio bursts. From the name itself you can understand that these are some fast something fast and something related to radio waves, and they are bursts. They are short bursts actually of electromagnetic radiation. So what happens is, if you are looking at the outer space using radio telescopes, right, then you can say that you hear a small anomaly in the form of some kind of a beep. Okay, and you hear some kind of a beep, and then maybe it will repeat again, right? So what happens is that you don't know where it is coming from, right? So there's very little known about these kind of phenomena. You can, if you look at this figure, you look at this is what I'm referring to as a beep, right? So if it occurs once, you don't know because it is gone. It usually stays only for a few milliseconds, which is the thousandths of a second. So it stays for very little time. So you cannot understand. But if they repeat over a period of time, that is when you can say, okay, maybe they're coming from that part of the sky, or they're coming from that part of the sky. That is when you can start studying them, right? So they are typically observed in radio wave frequencies. That is why they are called as fast radio bursts. Now you get the meaning of fast, you may get the meaning of radio, and you get the meaning of bursts, right? So they are coming from some unknown sources. We can say that, okay, maybe they're coming from some white dwarf or neutron stars, but we exactly cannot say. We haven't yet proven that where is the part of the universe where they're coming from, right? And because they lose their energy when they're coming to Earth, they are very challenging to detect. That is all about fast radio bursts, right? They are not easily detectable, and whenever you detect them, you have to wait for them to repeat in order to identify where they are coming from. and you don't know their exact sources, and they are fast, short bursts of electromagnetic radiation which are seen in the outer space, right? So those are FRBs. Now you come to GRBs, gamma ray bursts. Now they are something different. They are actually powerful and violent explosions in the known universe, and they are resulting from explosive events like maybe birth of black holes or collisions between neutron stars. So what are neutron stars? Neutron stars, any massive star, when it collapses on its own gravity and it's only the core is left, okay, that core is the neutron star, okay, then it's called as a neutron star because it is very, very dense. It is a very dense object, and usually a lot of neutrons are there. That is why it is called as a neutron star. It is a very, very dense object, highly dense, I mean unimaginably dense. All right, so when these two neutron stars, they very heavy dense objects full of gravity, when they come in contact with each other, there is a massive explosion, and then you kind of see these kind of gamma ray bursts. Right? These are bursts of gamma rays, and they are one of the brightest sources of electromagnetic radiation, and even brighter than the typical supernova explosions, right? So these are your gamma ray bursts, which can result from the collisions between neutron stars or even the birth of black holes. And what they can do here on Earth, they can actually affect the entire ionosphere. Ionosphere is the layer of atmosphere where charged particles are there. So it can impact that layer, right? It can ionize particles in that layer, and it can also temporarily destroy the ozone layer. So ozone layer, it is a protective layer that protects us from the harmful ultraviolet radiation, and gamma ray bursts have the potential to temporarily destroy this ozone layer. This is what the study conducted recently has found, right? So that's all about gamma ray bursts and the fast radio bursts, right? So yeah, that's all about them. Okay, so then let's continue with biotechnology and health. So you can see the list of topics over here. Some of them might sound familiar to you, like CRISPR and AMR and NCDs, right? And others are something new that we will look at. So CRISPR, there's some recent development, and gene drive is some recent development. CAR T cell is a treatment for cancer. AMR, everyone knows, antimicrobial resistance, and NCDs is non-communicable diseases. Then NSS stands for non-sugar sweeteners. We'll see what it is. Then Havana Syndrome sometimes comes up in news. Recently, a few days back, it was in news, so I included it. Then TB, always in news. So let's look at these. Definitely one of the most important topics over here. So let's look at these one by one. We start with CRISPR. Mostly everyone of you would know or would have heard about CRISPR. If you don't know what the process is, I will explain it to you in a bit. Right, but you know that it is a gene editing technology. It is it is the cheapest, most efficient technology that we have, right? And it is also one of the most important parts of our syllabus, because see, what happened is a few years ago, even the Nobel Prize was given to two women who developed this technology, right? Who had developed this technology, and now what is happening is that something new is happening in this field, which is why I am calling it 2.0. Everyone is calling it 2.0. Which means there's a new era. What is this new era? That it is actually now they are trying to use this gene editing technology on actual patients. So even the doctors have to start using it now. Obviously, there is no mass usage of this because it's not possible right now. But definitely, there is a step ahead. Casgevy is the first approved CRISPR-based gene therapy, right, for patients with sickle cell disease. So before discussing this, let's first go to how CRISPR works. All right, so it's not that complicated. It's fairly simple if you understand the concept. Cas9 is an enzyme, right, and it is a nuclease. So nuclease, you can understand it like a scissor, a molecular scissor, right? It is a molecular scissor, right? And then there is a guide RNA. There is a guide RNA, and they are clubbed together. So what happens essentially is that you have a DNA segment like this, which you have to edit, right? So for editing something, you have to go to a location, right? You cannot edit randomly anywhere, right? If you want to edit precisely, you need to know what is the location. So this is why this RNA acts as the guide. It will lead you to that location. It will lead you to that location where you want to edit the gene, right? Then this Cas9, you can understand now why there is a scissor attached, because this Cas9, what is going to do, it is going to cut this DNA fragment, right? It's going to cut this DNA fragment, and then now you can insert some new DNA fragment. That is how you have completed the process of editing. It's very simple, just like editing a text. You make typos while writing messages, and then you go back and correct it. You can understand it in a similar manner, though not as precise. CRISPR is not as precise, but still it is quite precise. It's quite accurate, and the process acts very simply. Cas9, it is coupled with guide RNA. They go to a location, then Cas9 this cuts the DNA at that part, and then you can insert the new DNA fragment, the new gene that you want to insert. You can put it over here. So this is how you will proceed with editing. So now what happens in sickle cell disease is, the sickle cell disease is also is a genetic disorder, right? So you only can solve it using a gene based therapy, right? You can edit the gene and then you can solve it, you can cure that disease. In sickle cell disease, what happens is that usually your RBCs, which are disc shaped, right, they become these sickle shaped. Sickle, you must have seen in farms. It is a farm instrument, sickle. All right, so it becomes sickle shaped. That is why it's called as the sickle cell disease, right? And for this, there is a treatment that has been approved by FDA in US, and that treatment is Casgevy. Okay, so what is happening is that they are using CRISPR to edit the gene, right? The hemoglobins, and they'll actually take out your blood cells and they'll edit the gene so that you start producing normal RBCs, right? The disc-shaped RBCs. So patients with sickle cell disease obviously have a lot of restrictions, because they face a lot of problems in regards to they can have severe pain at times. They can have blockages, and it can lead to a lot of other problems. So the best way forward for this kind of a genetic disorder is to treat them with gene-based therapies. But still, this treatment still is quite expensive. It runs into millions of dollars, and but at least there is a first step that has been taken in regards to CRISPR, which is that now they are going for clinical trials on patients, right? So maybe a few years down the line, you might see that this is becoming a technology in much wider use, right? So this gene editing, actually, here we are only talking about CRISPR, but gene editing in general, you must have heard about a lot of other things like GM crops, right, or GM organisms. So GM crops, most of you will know India has BT cotton, which is a GM crop. It is in use, right? Why? Because it produces the Bacillus thuringiensis gene is inserted from the bacteria, right? This gene is taken from the bacteria and it makes it pest resistant, so it can produce good quantities of cotton. So your cotton production will increase, right? Then you also produce BT brinjal in India, but it was not a success, so it was not continued, it was not used. Now recently there is another news about GM mustard, right? GM mustard, right? So what is GM mustard? Now notice one thing, that a lot of people make a mistake over here. They'll write it as BT mustard. It is not BT mustard. Whenever you write a BT crop like BT brinjal or BT cotton, what you're essentially saying is that there is a BT gene. BT is from the bacteria Bacillus thuringiensis. That is the full form of BT, Bacillus thuringiensis. Alright. So when you take that gene, that bacteria's gene, and you put it in the cotton or brinjal, it makes your crop pest resistant, right? But in GM mustard, you are not taking Bacillus thuringiensis, you are taking Bacillus amylofaciens. That is another, you can look at the spelling on your own. Bacillus amylofaciens, this is another bacteria that you are taking, right? And your objective is not just pest resistance, it is herbicide resistance, and it is also productivity. You want to improve the productivity, right? So this GM mustard in India, it is called as Dhara mustard hybrid 11, right? It is made of a hybrid of two varieties. One is Varuna and one is Hira, right? So it is made up of these two kinds of mustard varieties. The they're hybrid, and it is a GM crop because the gene of bacteria has been introduced, right? So Bacillus amylofaciens, as I told you the name, right? So the name of this GM crop, GM mustard, is DMH11. It is not BT mustard, it is GM mustard, and the name of the crop is DMH11. Now this Varuna, again this has been gene edited to produce a kind of mustard which has less pungency, right? Less pungency, because it has a, this pungency has been reduced because it has low quantity of glucosinolates, right? So because of this there is less pungency, and this is beneficial for livestock, because if it has high quantity of glucosinolates, then livestock can have problems related to some organs, they can have some kind of disease. So this Varun also has been recently, it has been done. So this is a news item that recently it has been edited to produce a less pungent version of mustard, right, which has lower quantity of glucosinolates, right? So that's all about that. Then we can move on to the next thing, which is gene drive technology. Now here also we are using some kind of genetic engineering, right? Some kind of genetic engineering to alter genes and disrupt typical inheritance patterns. So what are typical inheritance patterns, and why are we going to disrupt them? Let's have a look at this. First try to understand it from the case point of malaria. Okay, just understand it from the case point of mosquitoes and malaria. Right, so most of you will have a problem with mosquitoes. Why can't we just eliminate all the mosquitoes in the entire world? Why are they there, and what is the reason for their existence? Obviously, because they are insects, they play a role in have a role in the ecosystem. They have a role in the biodiversity. They do some mosquitoes also help in pollination. So all these different kinds of uses are there. They act as a feed for other insects. So they have a role in the ecosystem. But some mosquitoes are harmful to humans because they carry viruses which can cause malaria and dengue. Right? In malaria it's not a virus, but yes, in dengue it is a virus. So they can cause different kinds of diseases, right? They can cause malaria and dengue. So what if we can edit their genes in such a way that they cannot cause these diseases, right? We can do that, right? But we will do it in one mosquito. If we do it in one mosquito, right, and just imagine that this is a mosquito. If we do it in one mosquito, what happens is, in normal inheritance, it will not be spread to the entire population. Why? Because see, if the half of this mosquito's genes will be passed to the next offspring, right? And half of this mosquito's genes will be passed to the next offspring. So you can see that gradually the wild mosquitoes have taken over, and the genetically altered mosquitoes have a low chance of survival, right? They have a lower chance of survival because the wild mosquitoes will still be in large number, right? This gene is not being transferred to other populations, other wild mosquitoes, right? This is exactly what we change in gene drive inheritance, right? This is exactly what we change. What we do is, in mosquitoes, this is the gene in the mosquito, right? So what we do is, we alter this gene by inserting the new gene. New gene is there. We also insert the guide RNA, and we also insert the Cas9, right? We are talking about this red mosquito. We have altered this gene by introducing the Cas9 plus RNA, guide RNA, and the new gene, right? And now, when this mosquito mates with the other mosquito, when this mosquito mates with this mosquito, what happens is that this Cas9 and the RNA, let me draw this with blue because it is the blue mosquito, right? So what happens is, in this blue mosquito, this RNA and Cas9, they will go along with this new gene and they will edit it, right? Because there is Cas9 and there is RNA, so you can go to that location and you can cut it out, and you can put the new gene over there. So now this mosquito's genes also will be edited, right? This mosquito's genes will also be edited. So now you can see that later in the population, what is happening is that this process keeps on repeating at every stage, and in the end you have all the genetically altered mosquitoes, which cannot cause malaria or dengue. This is what is known as gene-driven inheritance. Gene-driven inheritance, like gene-drive inheritance. Right. So, gene-drive inheritance is meaning is genetic engineering is altering genes to disrupt typical inheritance patterns. And genetic material inserted into the animal DNA to replace the natural genes, just like I gave you the example of mosquito. Applications are, as I told you, target mosquitoes to control malaria, dengue and Zika, and even ecosystem management by controlling the invasive species like rodents, like even plants. So these are the applications. You need to know the applications. You need to know what the meaning of this technology is, right? And you obviously need to know about gene editing and its applications. So that's all about this. We can continue with the next item, that is CAR T cell therapy. Now this is in news because an indigenously developed version of this technology has been used by on a patient, has been used on a cancer patient in India, right? So this technology was developed by IIT Bombay, and this is the name of the technology that has been developed indigenously. Otherwise, CAR T cell is not an indigenous technology, but they have developed NextCAR19, which is indigenous. Okay, so before that, before talking about that, let's talk about the CAR T cell therapy, what it actually is. So CAR T cell therapy is a therapy to treat cancer, right? So what happens usually is that you have certain cancer cells in the body, right? These are cancer cells, and then you have immune cells in the body like T cells, right? So these T cells, they recognize the cancer cells and they attack these cancer cells, right? This is the work of the T cells, right? You must be knowing about T cells and B cells. T cells provide cell mediated immunity, B cells provide humoral immunity, right? See that these are the basics. So T cells can actually kill cancer cells, but sometimes what happens is that these cancer cells, they become very large in number, and they undergo a lot of changes to evade this killing by T cells. So these cancer cells, either they will develop a lot of antigens on the surface, or they will become very strong, right? Or they will do some kind of changes to their own structures. Then these T cells will no longer be able to attack these cancer cells, right? So then this becomes a problem. So then what do? You edit these T cells, right? You edit these T cells, and what do you put inside them? You put chimeric antigen receptor, right? Chimeric antigen receptor. You put a chimeric antigen receptor gene, right, which is going to develop, right? And then what happens is, then these T cells become effective, and then they can effectively attack these cancer cells once again, right? So for editing these T cells, you need to take them out of the body. So what in the process, it's very simple. The process, what happens is, the healthcare providers, they collect blood to obtain T cells. Then T cells are separated and removed, right? And blood is returned to the patient. Then these T cells are genetically altered to insert chimeric antigen receptors, like I told you, right? Then they are grown in the lab, and then they are given to the patient's bloodstream, right? Obviously before then there is some chemotherapy, which means some kinds of drugs will be given, some medicines will be given, that is medical procedures. But these chimeric antigen receptor T cells, or CAR T cells, they can effectively destroy cancer cells, right? So that is how you cure, that is how you treat cancer, right? The research is already, there is more research going on in the topic, but yes, this is one therapy that has become prominent. So one of the CAR T cell therapies that has been developed by IIT Bombay is called as NextCAR19. Okay, this is indigenous, so you need to know the name NextCAR19, and this is attacking the CD19 protein, which is on the B cells. Okay, which is on the B cells. So it is used to treat B cell lymphoma, right? So B cell lymphoma. So basically CAR T cell therapies, they are used to treat currently they are used to treat leukemia and lymphomas. So for this B cell lymphomas, you have NAXCAR19, right? So you got the definition. What is the CAR T cell therapy? You know that T cells are natural immune cells. Then you know the news, and you know what is the purpose of this technology. You know what is the application, and you know what the mechanism that I've already told you, right? Then let's move to AMR. Most often it is in news because of obvious reasons, because we want to reduce the antimicrobial resistance, right? Because it is very harmful for the health of millions of people all around the globe. So what is antibiotic resistance? It is the resistance that microorganisms develop because of the overuse or misuse of antibiotics, right? Or antibiotics, or even other kinds of antimicrobials, right? So basically when you talk about AMR, we will be talking about antibiotics only, right? So antibiotic resistance, how will it happen? When there is over prescription of antibiotics. You are using a lot of antibiotics, so the bacteria, after some time, they become immune. So they will no longer be responding to the antibiotics. You give the antibiotic to the patient, but the bacteria is not getting killed. The harmful bacteria are not getting killed, right? Or the patients are not finishing the treatment, right? So the bacteria, even when they were killed, they were not completely killed, right? They were not completely some that remained, they had developed the immunity. Then there is overuse of antibiotics. The same kind of thing will again happen. Antibiotic resistance will be there. Then poor infection control is there in hospitals and clinics. Lack of hygiene, lack of new antibiotics being developed. All these culminate into causes for antibiotic resistance that is actually already creating harm on several different levels. So in partnership with Global AMR and R&D Hub, WHO has released the incentivizing the development of new antibacterial treatments report. So that is the news item, that is we can look at it, but more important thing is to understand that what is AMR, what is the cause of AMR, right, and what are the different steps that have been taken by India and WHO. Right, so if you look at the WHO, there is a global action plan, there is Aware, Access, Watch and Reserve. What is Aware, Access, Watch and Reserve? Aware means these are antibiotics that you can use, right? That won't result in AMR, or that have low chances of resulting in AMR, right? Then watch is those which have a chance of resulting in AMR, so you should watch their use, you should reduce their use. Then reserve is the last course, like the last resort antibiotics, which should be used only when there is no other solution in place, right? So this is the system that has been prescribed by WHO. And then there is a surveillance system of WHO for monitoring the global antimicrobial resistance, right? And then there is a One Health plan. One Health means you cannot think only about the health of human beings. If you are actually thinking about the health of human beings, you have to look at the One Health concept. One Health means looking at the ecosystem, the environment as a whole, as a system, rather than only human beings, right? You need to take care of the environment, the ecology, the biodiversity, as well as the health of the animals as well, right? So that is the meaning of One Health. So this is obviously this plan is there by the FAO, UNEP and World Organization for Animal Health, right? You can read on your own. Then there are different steps taken by India. So there is obviously a national action plan, right? For every global action plan, most of the times there is a national action plan in India also. At recent G20 summits, there is a Delhi Declaration on AMR, right, which obviously is talking about tackling AMR on a global level. Like by the G20 countries, there has been a declaration called the Delhi Declaration, right? Then there is a national AMR surveillance network also to monitor the incidence of AMR, and there is a red line campaign, which means that if there is a red line in a medicine, if there is a red line attached to it, then it requires a doctor's prescription. Similarly, Schedule H1 drugs also require a doctor's prescription. They cannot be sold over the over the counter, right? You need to show the doctor's prescription for such kind of medicines, such kind of antibiotics, right? What is this doing? This is reducing the misuse or overuse of antibiotics. All right, so that's all about AMR. So much in news all the time. Then there is another topic which is so often in news, that is the non-communicable diseases, and it's becoming very relevant now, right? We always talk about the communicable diseases, but There are some diseases which cannot be transmitted from person to person, but what are they? They are lifestyle diseases. They are affected by your routine, by your food, right, by your environment. So there are a lot of causes for these kind of lifestyle diseases, and so many people are being affected by it, right? So Ministry of Health and Family Welfare has released a strategic operational guidelines for National Program on Prevention and Control of NCDs. This plan will run till 2030, and there are two initiatives. You can see 75 by 25 initiative, which means that we have to put 75 million people who are dealing with hypertension and diabetes on standard care by 2025, which means that they'll require care, they'll require healthcare facilities, they'll require hospital facilities, diagnosis, treatment. So we have to find this. We have to put 75 million people into standard care by 2025. Then there is a portal, Sashakt portal, which will provide training to primary healthcare medical officers so that they can effectively deal with cases of NCDs, cases of non-communicable diseases. So what are the examples? Two examples you have already seen: diabetes, hypertension, then BP, the blood pressure, and other kinds of similar kinds of diseases are there, which are non-communicable, and yet they are causing damage on a large scale, right? So even your cardiovascular diseases will come under this category, right? So another thing that was recently there was regarding non-sugar sweeteners, that what WHO has said is, usually what you hear is, especially in people who have sugar, or even if they are they are very diet conscious, what they will do is they'll go for sugar-free foods or diet foods like Diet Coke that you get in the markets, or sugar-free things. Sugar-free. There is a lot of products. You must have seen the advertisements, right? So obviously there is no sugar in it, but there are definitely some other chemicals, and those chemicals, WHO has said, they are not effective in weight loss, right? So they are not reducing your calorie intake. They are not causing weight loss, and they might be causing other kinds of harm, right? So you need to be cautious while considering these kind of products, because they might be causing other kinds of problems in the body, right? So if they can cause stomach problems, or they can cause headaches, or even other symptoms have been seen, right? So long-term usage of these non-sugar sweeteners, right, these sugar-free products, these diet Coke type of products, this is not healthy, right? So NSS, these non-sugar sweeteners, they contain few to no calories but are sweeter per gram. This is one characteristic, that they are actually more sweet than the sugar, and that's one characteristic. Examples are table sugar and fruit juice concentrates. Compared to these, they are sweeter. Non-sugar sweeteners are sweeter than the table sugar and the fruit juice concentrates, right? Then they are referred to as low-calorie sweeteners or artificial sweeteners also, right? And they are used to enhance the flavor of foods and beverages. They include synthetically derived chemicals and natural extracts. Obviously, they are made in the labs, and they are found in a variety of products, including beverages and frozen frozen desserts and yogurt, like I told you. Okay, so these kind of things, they are what many of these kind of things, and many of things related to your diet, your lifestyle, your environment, they all become the cause of non-communicable diseases. For example, air pollution, right, is also a cause of non-communicable diseases, respiratory issues, right, or cardiovascular issues, right? So many of these things, you need to keep a tab on these items in the news. Keep looking for these kind of things, because they are important, right? Then let's move on to the next thing, which is Havana Syndrome. Now this is I mean, a few days ago there was some news regarding it, that scientists have found no trace of harm in people who experienced Havana Syndrome. So actually Havana Syndrome, it happened a few years ago. Some officials from US, when they went to Havana, and there is a place Havana. Okay, so over there they experienced these kind of symptoms: very intense pressure in head, or difficulty with memory, nausea, right? Very pointed pain in the head, right? So all these kind of symptoms, and these symptoms could last for weeks or months, right? And there was no identifiable cause for these symptoms, right? There was no understanding of how is it happening, what is causing all this. So No definitive cause was found, but scientific studies have noted the accused systems are consistent with exposure to direct radio frequency energy or microwave or microwaves or some other kinds of things. Some people even said they were maybe wild insects which could have led to this. But recently scientists have found no trace of harm, any kind of medical illness or injury in people who experienced Havana Syndrome. So you can just refer to this whenever it comes in news. As something for the exam, I think the terminology is more important, right? So let's move on to tuberculosis. Again, tuberculosis, it's very often in news. The reason is that we have the mission from campaign. The Ministry of Health and Welfare launched the Tuberculosis Mukt Bharat Abhiyan, right? And we have the campaign to end TB by 2025, that is next year. So that is why it is going to be important, because it is going to come up in the news. And that is the mission that we have. But what is TB? So TB is actually a bacterial disease. Mycobacterium tuberculosis is the name of the bacteria that causes this disease, and it can be both pulmonary, which will affect the lungs, or extrapulmonary, which will affect different other parts of the body, right? So the treatment, you can see the names of these drugs. You don't need to remember for exam, you don't need to remember the names of these drugs, right? But you just need to remember that these are different lines. So there are different lines of treatment for TB, because first line is the antibiotics, which have less power. Then if these are not effective, then you go to these kind of drugs, and if these are not effective, both of these are not effective, then you go for the next kind of drugs, right? So the treatment can be 4, 6 or 9 months long, and most latent TB infections are treated for 3 or 4 months. Latent means the virus is there but the symptoms are not there. Okay, and then the prevention is the BCG vaccination, right, which is a live attenuated vaccine, right? So that's all about TB. And if you want to know what is live attenuated means just the virus is there, it has been weakened, right? It is a weakened form of virus that is given as a vaccine, right? So that's all about TB then. Okay, so let's move on to the next one, which is IT, communications, robotics and AI, all these technologies, right? So these are the recent developments that you see in front of you. All these are recent developments in these areas, and we'll look at them one by one, right? About regulation in AI, Anhtrobots, crypto assets, Web 3.0, what is Wi-Fi 7, what is FSOC, right? Then something related to self-driven cars, AR and VR, quantum mission, and India's own operating system, BharOS. So let's look at them one by one. Right, so let's start with AI. Definitely, you know what is AI. It is when the machines, when the machines are trying to behave like humans. All right, they're given some programming. They're given some some code is written, and they try to mimic human behavior in some form or the other. Right. So there are definitely there are different kinds of applications related to AI, but there are also certain kinds of concerns and issues related to this, right? So recently Google Gemini, right, so it had some kind of bias associated with it. So all these are different kinds of issues are there about privacy, about data security, right? So there's this AI safety summit which was held recently at Bletchley Park in London, and it adopted the Bletchley Declaration, which is there to regulate AI. So it is the world's first agreement on AI, and India is also a part of it. So that is why you can understand why it is important, right? So in your exam, the question can just be like Bletchley Declaration is related to. So you must know what is it related to, right? So if you specifically look at AI, you know all the different kinds of applications, right? I mean, there is no end to how you can apply AI. Anything that you can think of right now, in some point in the future, it will be impacted by artificial intelligence, right? So whether it's healthcare, whether it's finance, autonomous vehicles, natural language processing, which is your chatbots like ChatGPT, and if you know, India has also one recent unicorn by the name of Krutrim. It has developed India's first AI chatbot, right? So all these things are applications. Then e-commerce and retail also has applications, manufacturing, education. So everywhere, I mean, you can read this on your own, but most of the times you will find that what is the AI helping you do? They are trying to help you improve the productivity, help you improve the efficiency of operations. Like in manufacturing, it is optimizing production processes, right? Or in e-commerce and retail, it is trying to give you better recommendations of product, or helping you better, look for your own kind of better, whichever product you are looking for, it will give you a better recommendation for that. Or if it is talking to you like in chat GPT, or it is driving cars on the on its own, or it is used for fraud detection in finance, risk assessment, trying to understand what are the different kinds of risks associated with finances by predictions, because it will have a big data set. What usually happens is there's a big data set, AI will study the patterns, and then it will be able to predict some future events, right? So that way you can use it, and it is called big data analytics, right? That is called big data analytics, right? So those kinds of things are there. And then the healthcare, definitely diagnosis question last year was asked in mains, medical imaging, personalized treatment, all these are places where AI can definitely be used, right? So there's one recent event around the issue of deepfakes, right, which is related to AI. So what happens in deepfakes is it alters the visual or audio content, which is whatever is the real content, it alters it and it looks like it is real. It makes it looks like it's real. So even the Prime Minister's video was altered, some famous actors or any kind of all these kinds of different politicians, their video was altered using deepfakes. It's a combination of the word deep learning and fake, which means AI was used to convert a fake video and make it look like a real one. Okay, it was used to make it look like a real one. So what was it? What was it essentially doing? It was a case of identity theft in one manner, fraud or impersonation, right? Someone else's face being used, and it is modified in a certain way so that it looks like someone else, right? And then it compromises on it compromises on the security and privacy of the users, right? So deepfakes, it was definitely in news, and it was a cause for alarm, right, about AI safety. So Union government has issued an advisory to social media intermediaries to identify misinformation and deepfakes, right? Because it can create a lot of confusion, lot of chaos. Tomorrow, if some some speech of some politician comes out, it can lead to some kind of maybe some kind of disturbances in some areas, or people might start believing it, and they can fall prey to such kind of videos. So it can be used for political manipulation as well. So all these kinds of different concerns are there around the issue of deepfakes. That is why this advisory has been issued to the social media intermediaries, right? Then we come to brain-computer interface. Now, this is again, if you have read the newspapers about Elon Musk's Neuralink, right? His company is Neuralink. So what they have done is they have implanted the first chip into the human brain, right? So that is actually your brain-computer interface. That is nothing but brain-computer interface. What is brain-computer interface? Facilitating direct communication between the brain and external devices, right? So you can see in the figure also, what is happening is you're like you're thinking something and it's coming up on the screen. So that is the basic meaning of brain-computer interface. Now, it's not necessary to implant something directly into the human brain for a brain-computer interface, right? You can there are all kinds of ways. So if you have seen, there are some kinds of nodes attached to the brain. Sometimes those are non-invasive interfaces. If you are just attaching it by what you call above the membrane, if you are attaching above the skull, right? So if you are attaching it like that, then maybe it is semi-invasive. But if you are implanting it directly into the brain, then it is quite invasive. So that is what has been done, and that is why this topic was in news. And this technology, it has different kinds of applications. Essentially, in this, what you are doing is you are understanding the brain behavior, right? How brain is behaving. What are the, if you're thinking something, it's coming up on the screen. If you're thinking about moving your hand up, so it will automatically do that. So how is it helpful? It is helpful in medicine. Why? Because it can be used for assistive technology. People who have individuals with paralysis, they can be used to control devices, right? And then it can be used to monitor mental health. It can study the patterns in the brains, and it can help in the management of these conditions like depression, right? Then there are medical treatments, like it can help you in treating neurological disorders or rehabilitation after a stroke. So these are medical applications. By understanding the brain behavior, you can help in developing these solutions. Then it can obviously virtual and these are entertainment applications that can enhance your digital experiences through brain interaction, right? Though I think he gave the example of playing music in your brain, and he was also giving example of memory. If you can if you can store memory in those chips, then you can later download it somewhere else. I mean, those are far fetched things, because some scientists will say that it's not that easy. The memory is embedded in the organic tissue. So anyway, I mean, they are thinking in that direction. That is so too far fetched. But for our understanding, you need to know what is brain-computer interface. You need to know that it can be non-invasive as well, it can be invasive as well, and it can be partially invasive as well, and the different kinds of applications, right? What are the different kinds of ways in which you can apply this technology for societal benefit, right? So that's all about brain-computer interfaces. Okay, so let's move to AR and VR now, augmented reality and virtual reality. So let me first clear the air around what is AR, VR, and MR, because these terms come around a lot of times and they can become confusing, right? And together these are called extended reality, okay? XR, extended reality. So what happens in AR is that it is an augmented reality. Augmented means there's you wear that kind of all these kinds of instruments. These are they will you can look around the things that are there around you. You can look at the real things around you, but you can attach virtual objects also, right? You can place if you're buying a sofa, maybe you can place a sofa and you can see, okay, is it fitting in this room, is the color matching, everything you can do, right? In VR, what happens is that it's completely virtual. You cannot see the real world around you. It's completely virtual, like you're playing a game, right? Or if you are playing those virtual reality apps, if you are using those, so it's a completely virtual environment, right? And what is mixed reality? It's a mix of both AR and VR, which means that there are some elements of interaction also, right? Like if you're placing a sofa, maybe you can increase your size, increase or decrease the size of the sofa, right? And there are some elements of the real world also around you. So what I'm saying is, in AR you cannot interact with anything that you see, right? You can just see virtual objects in the real world using those kind of devices, right? But you cannot interact. In VR you can interact, because as I gave the example of playing a game, you can interact also, because you're playing a game, but you can only see the virtual world, you cannot see the real world. In MR, that is mixed reality, you can also see the real world, and you can also attach the virtual world in it, and you can interact with that world as well, right? So this is the basic difference between AR, VR, and MR, and you can read the applications over here. All these different applications are given, right? So this industry is expected to reach, you can see, such a massive amount by 2025. You will find new apps coming in which are using these kind of technologies, right? And already you have seen Apple Vision Pro and Metaverse, all these devices coming in which are using this concept of AR, VR, and MR, right? So I mean, there's a horde of applications. If I briefly touch upon a few, you can talk about highly realistic training. Like you don't have to take people underground to teach them about mining or oil extraction. You can just create a virtual world, right? And you can they can wear those VR headsets, and they can look around, and then they will notice the same kind of an environment, and then you can teach them in that environment. You don't need to take them in risky places like like those underground situations, right? Then it can also be used for what do you say in healthcare training and access to care for patients and caregivers through telemedicine, right? The doctors, they can you can see doctors can examine the patients from a distance, right? Then surgery assistance can be provided, right? So similarly, all these applications are there. In retail, they can be virtual, never-ending aisles for you can walk around like you're walking in a supermarket. So all these things you can use all these ways you can apply AR, VR, and MR, and you will find all these things. In the future you will find many of these kind of apps coming in already. In Amazon, if you go, I'm not sure about Flipkart, but I definitely know in Amazon, if you go, you can see that feature. View this. If you, for example, if you're buying a chair, you can there will be an option of view in your room, right? View in your room. So that is an example of AR, right? So you'll find different kinds of apps coming in the future, and then you will understand how these are being used, right? Then is the thing about Anhtrobots. Now, what are Anhtrobots? They are the first fully cellular biological robots made of human cells, right? So they are these tiny robots of the size of human cell, right? But they can move on their own. They can perform some functions on their own, and they have been tested in the lab, and they have been seen to provide benefit to some kind of damaged tissues like damaged nerve cells. So they have been created out of human lungs. Here they have been seen to fuse together to form a super robot which was able to encourage the growth of neurons. So they have been seen, in some ways they have been healing some nerve cells, in other ways they have been healing some other damaged tissue, like the example over here, where human lung cells were capable of moving independently and they healed some damaged tissue, right? But remember that these human cells, they just have a different biological architecture, which means they can move on their own. That is why they're classified as robots, and they are made of human cells. That is why you're calling them Anhtrobots. But there's no genetic modification that has been done in this cell, right? So please remember, this is an important point, that you might confuse that, okay, there might be some genetic manipulation. No, that has not been done. There's just been some kinds of tweaks and alterations in their mechanism, right, to make them kind of autonomous, right? So in the future, what can they be helped? What can they help us? They can use for drug delivery. Definitely, if they can move around, they can as well go and deliver drugs, or they can repair some spinal cord or nerve damage, as I told you. They can also sense tumors. You can attach sensors to them, and they can sense tumors, or they can repair wounds, as I told you, right? And even the blockage of arteries, they can go and clear those, right? So what you can do is there's something called xenobots. You can look up what are xenobots. Anhtrobots are you can say an improvement over xenobots. This is an old term, but definitely look this up. It was made from the cells of frog, and this was also a kind of robot only. But you can read how is Anhthrobot different from xenobots, right? So let's move on to the next topic, which is Web 3.0. Now what happened is, when the World Wide Web was developed initially, it was called as Web 1.0, right? And anything you see, anything that you study, most of the times what happens is that it evolves over time, right? It evolves over time. There's more additions, there's more technological advancements, there's more complications. So all these things they advance over time. Like your industrial revolutions, you have seen there. We are going through the fourth industrial revolution right now, right? Similarly, for Wi-Fi, you will see we have different standards. Now we have the more advanced standards. Similarly, there is different generations of web as well, right? So web 1.0, from web 1.0 we move towards web 2.0. This is where we are at right now, and in the future we might be moving towards web 3.0, right? We'll understand what is this. So web 1.0 was just read only web. Read only means you can just it's like a Wikipedia page. Just reading you can just read. There's limited scope for interaction, or there's no scope for interaction at all, right? But in web 2.0 what happened is your Facebook came, your YouTube came, your Twitter came. So now you could interact also. Your social media was there, so you could interact. So now we are currently in web 2.0, where we can interact with the content that we see on the web, right? So what is web 3.0 now? Obviously there would have been something that happened in web 2.0 which would have influenced the evolution of web 3.0. So what happens in web 2.0? You all know, you search about something and you get an ad instantly. So what is happening? You are browsing through a website. Your data is, whatever you are browsing, your data is given in the form of cookies by some third parties. It is being sold to some company, right? And those companies, they target ads. Based on that data, they will target ads on your web page, right? So now this is a concern, because people will say, okay, my privacy has been compromised and my data has been sold over, so I want more autonomy. I want all these third party cookies to be removed. So that is what essentially web 3.0 is going to do, right? Your web 3.0, first of all, there you can say that there are 4 components in which 4, or you can say 4 ways in which web 3.0 will be different. First of all, it will be decentralized. Decentralized means the data will be stored in the form of blockchains, right? So several computers will have the data stored with them, so it is very difficult to alter with the data, right? So it is a decentralized form of web. Second thing is that the third party cookies that I was talking about, they will not be there, right? So you will have more autonomy over your data, right? So that will not be there. Then it will be more of a semantic web. Semantic means it will understand what you are saying, right? Just think about ChatGPT, right? The evolution of ChatGPT currently. So it will understand what you are doing. Semantic is related to words, so it will understand words in a more human kind of a manner, right? And then more devices can be connected, which means that will not be limited to your PCs and smartphones. It will not be just limited to your PCs and smartphones. So these are the features of web 3.0, right? Where you will be using your blockchains, where you will be using your artificial intelligence, right? You will be using your chat GPTs and all those kind of things, right? So it's a more, you can see that it's a more trustable, it's a more trustworthy web. It's a more trusted form of web, right? So these are the features, and what is being said in this report is, this report is titled "Unlocking the Web 3 Potential: India's Journey from a Talent Exporter to a Product Powerhouse." Talent exporter, the concept of brain drain, and then the product powerhouse, which means India is producing, India has a lot of startups now. So this report was released by Primus Partners, and it said that in 2022 India held 11% of the world's Web 3 developer pool, which is ranked 3rd worldwide. So Web 3 developers in India, there are a lot of Web 3 developers, about around 11% of the global number. Then Web 3 sector is projected to create 2.2 million direct jobs in the next decade. Right, so you can understand the reason why, because we are moving towards the Web 3.0 right now. Okay, so this is the feature of the report. That is why it was this term was in news, or most of the time Web 3.0 is in news, because we are moving towards that. Here you can see the differences that I've already told you about. You can read the slide on your own. Right, the static web, Web 1.0 was called the static web, 2.0 was called as the interactive web, and Web 3 is called as the decentralized web, as I told you. Right, so let's move on to the next one. I've already explained all these points, so you can just if you want, you can pause the slide and you can read. Alright, so let's move on and let's look at Wi-Fi 7 now. As I told you, everything goes through some kind of evolution. So even Wi-Fi, it has it has evolved, and now the latest technology that has come up, it's called as Wi-Fi 7. So Qualcomm, you might know the company Qualcomm. It has suggested India should adopt the newest Wi-Fi 7 technology. Right, it represents the next Wi-Fi generation standard. So any router that you have in at your home, you must have seen around Wi-Fi routers. They run on a standard Wi-Fi standard. Right. So right now most Wi-Fi standards will be either 6 or 6E. So now we are moving towards Wi-Fi 7 standard. Right. So you can obviously guess. See, in exam or anywhere else, if there is a new technology, obviously it will be an improvement over the earlier one, right? So you cannot say that Wi-Fi 7 will be slower, right? It will obviously be faster, right? You cannot say that it will carry less data. It will carry more data, right? It will not have a lesser bandwidth. It will have more bandwidth, right? It will be more flexible. So all the things will be improvements, right? You cannot say that Wi-Fi 7 is worse. I mean, there can be some limitations attached to it, and that is understandable. Like you talk about in 5G or 6G, there 6G can have limitations. Definitely that can be there, but in terms of speed, in terms of other kinds of improvements, definitely it will be better. It will have lower latency rates, which means lower delays. You click a button and immediately you can find the effect on the screen. Those who do gaming will understand what I'm saying. Low latency is very important for them. So all these things, sometimes you just apply common sense, you already know the features. It's over here also. If you look at the features of Wi-Fi 7, what happens is that it doubles the available bandwidth, which means bandwidth is the maximum transfer capacity, right? So there is more capacity of the network to carry data, right? Then how does it double? I mean, you don't need to go into the details of it. As it uses a 320 megahertz band, which is very wide. It's like you can relate it to a national highway. It's a very wide road, so more traffic can move it, right? Then it uses one more channel, 6 gigahertz. So if at your home or anywhere else, most of the times what you'll have is 2.4 gigahertz, and update those who have upgraded Wi-Fi, they will have both 2.4 and 5 gigahertz, so you can connect to either of them, right? In your phone, if you get two options for your Wi-Fi connection, and one is labeled as 5 gigahertz, which means you have both 2.4 and 5 gigahertz. In Wi-Fi 7, what happens is you have 6 gigahertz also, 2.4, 5 and 6 also, and you can simultaneously work with any of these. So how does it make a difference? The thing is, if you are using 2.4 gigahertz, it can pass through walls very efficiently. So even if you are far away from the router, it will work nicely, but the speeds are going to be a bit slower, right? But if you are using 6, the speeds are going to be faster, but it cannot penetrate as good as 2.4 gigahertz through the walls, right? So 6 gigahertz, it's a bit difficult to penetrate through the walls. So if you are sitting close to the router, 5 or 6 gigahertz will work better. But if you are sitting far away, 2.4 will work better. So it can simultaneously change the states in Wi-Fi 7. You don't need to connect to a specific gigahertz, right? You cannot need to connect to a specific band. It will automatically connect whichever is more convenient, right? So that is there in Wi-Fi 7. Then 4K QAM, you don't need to know what is 4K QAM or anything. Just understand that there is lower latency. Lower latency, as I told you, is lower delay in your operation, right? Whatever you do, you can immediately see the effect of it on the whether you're playing a game or you're watching a video or anything else, right? So it is going to have lower latency, right? Faster speeds, lower latency, and more bandwidth, right? So one of the things that in the exam they might ask you, so please know that bandwidth is maximum capacity and throughput is the density of the data. Density means you can understand like how much data is passing per second or per time interval. So what is the density of the data? How is it being transferred, right? So this is the basic difference between bandwidth and data. Bandwidth is the capacity and throughput is the density, right? So let's move on. That's all about Wi-Fi 7. Let's move on to FSOC, which is free space optical communication. Okay, so optical communication, it's going to use visible light for communication, right? So example, as you all know, is Li-Fi. Li-Fi, what is that? It's called light fidelity, right? So just like your Wi-Fi is wireless fidelity, it uses radio waves. Li-Fi uses light, your visible light, right? Like your light bulb for connecting to internet. Okay, so they are predominantly used indoors, utilizing light from the visible spectrum, and they operate on visible light communication, and they can transfer data faster than Bluetooth and with no electromagnetic interference, right? So the thing is that FSOC is not used indoors. It is an outdoor optical wireless communication technology. That is what you need to remember. The difference is that it's a free space. That is why they're calling it free space, because it's an outdoor optical wireless communication technology. And why we are doing it is because Alphabet, the parent company of Google, it is executing a project Tara, under which it is deploying light beams internet technology in India, Africa, and other regions, right? So basically what they are trying to do is use this technology of visible light communication for improving connectivity of remote regions, right? Remote regions, they are not easily connected to internet, so many different kinds of projects are there. You know about the Starlink project of Elon Musk, which is it's not based on optical communication, but it's based on satellite internet, right? Similarly, so Project Tara is based on optical communication, right, to provide internet to these kind of remote regions. But there definitely there are some limitations, right? Because if there is fog or if there is haze, then communication can be hampered, or if there is some birds flying around, then it can definitely impact the communication, because optical communication is a line of sight communication. Visible light, as you all know, if you turn on the light, you need to be, if you go out of the room, can you see the light? No, right? So visible light, you need to be in the line of sight. It's a line of sight technology, which means that you need to be in the line of sight to communicate, right? So that is one drawback of it, that this is why some other kind of interference can it can impede the data transmission, right? Then this kind of communication will support data, voice, and video communication at up to 10 gigabytes per second through full duplex connectivity, similar to optical fiber cables. You know about optical fiber cables. They use the concept of, these are cables which use the concept of reflection of light to transfer data, right? But here what you are doing is you are using optical beams through free air. That is why you are calling it free space optical communication, right? So there were different kinds of application. You can definitely use them in military, right? Last mile access, as I told you about, remote areas, and telecommunication and computer networking. All these kinds of things also you can use, right? So that's all about free space optical communication, right? So then let's come to advanced driver assistance systems. Okay, so advanced driver assistance systems, from the name only you can understand that these are systems which are assisting the driver, or these are advanced systems which are assisting the driver in some way or the other, right? But these are not, you cannot say that this is equivalent to autonomous vehicles. No, I'll tell you why in a while. But advanced driver assistance system is you can say it is an umbrella term for all the other kinds of features that can come in the in car, which will enhance the autonomy of the car. All right, so let's look at the news item that India witnesses a surge in demand for these systems, marking it as a growing market for such technologies, right? So ADSS comprises electronic systems integrated into vehicles to enhance driver safety, improve vehicle performance, and provide convenience. I mean, that is common sense. Why will you have autonomous vehicles? Because you want more safety, you want better performance of the vehicle, and you want a bit more of convenience, right? So it will, what will it use? It will definitely use some cameras, some sensors, right? It will also use radar, right, and some other technologies to monitor the vehicle's surroundings and detect any kind of hazards, and then it will automatically after detecting these darts, either it will help you park the vehicle, or it will help you accelerate the vehicle, or in general completely automate the vehicle. So all these are different components that are there in the in these ADAS, and there are different levels. Okay, the different levels. So let's look at the different levels of ADAS. Then you will understand it in a bit more of detail. So you can see that there are 5 levels. Sometimes there are, some people will say there are 6 levels. Okay, so let's understand it in a bit more simple manner in 5 levels. What is the meaning of ADAS and autonomous vehicles? So you can see that first 2 levels are advanced driver assistance systems. Okay, and after that you move to autonomous vehicles, which is also advanced driver assistance system only, but you call it autonomous vehicles. So in first level, what happens is that it's only the driver. It's all up to the driver. There is no support from the vehicle. The vehicle, it does not. It can only give you some alerts, but it will not assist you. Right? It will not have any kind of advanced technologies. Right? So you have to give your full attention. Right? So that is all your level 1. In level 2, what you can do is that vehicle can control the speed, and it will also control the lane keeping. Lane keeping means there are different lanes, right? So your vehicle can can move in the same lane. That can be ensured by the vehicle autonomously. You don't have to worry about that. Okay, so the driver and the vehicle both are involved, but you can see that the driver still has more role, right? When the driver has lesser role, right, and the vehicle is controlling controlling most of the operations, and it informs the driver when intervention is needed, right? So it's not completely, it's not completely like you can sleep in the car, but if the car alerts you to take control, then you have to take control, otherwise it will go on its own, right? If you can see that in level 4 it's eyes off, which means vehicle is in full control except a few situations. So most of the times you can trust the vehicle. It will move on its own, because it is highly automated, right? And in the last level 5, what happens is, even if there is no human sitting inside, the vehicle will still move on its own, right? There is no human required in the vehicle. So that is the level 5, which is full automation. So these are the different levels. Most of the times, most of the vehicles that you see around right now, most might be either level 1 or level 2, right, or some level 3, right? But level 5 is very difficult to achieve. It has not been. I mean, the work is going on. It is very difficult to achieve, right? So these are the different levels of ADAS. Right? Now let's come to crypto assets. Alright, so crypto assets, as you all know, what are crypto assets? Crypto assets are some kind of digital, you can say digital identification for some kind of value or some kind of rights, right? Like your cryptocurrencies, right? Or your NFTs. NFTs are, certificates of authenticity, digital certificates of authenticity, right? Like you buy a painting, or you buy you can buy some content, and you can say that it is mine, right? So it is there will be an NFT, there will be a digital certificate of authenticity, right? So it will be like an ownership certificate, right? Then there are cryptocurrencies, right? Cryptocurrencies which are used to trade, right? So there are different kinds of crypto assets. There can be other crypto assets also, like security tokens. They can be utility tokens. There are different kinds of all kinds of different ways in which you can use. The overarching term is crypto assets, because these are digital representations of some kind of value or rights. And that is what you need to know. So what has happened is, European Parliament has passed this markets in cryptocurrency legislation to regulate the cryptocurrency, because all that these things are very new, and they are not yet properly regulated, right? So they have established a legal framework for crypto asset service providers and enhanced consumer protection. So it focuses on regulating categories of crypto assets currently outside existing regulations, and you can see that although they have regulated crypto assets, some kind of assets have been excluded, right? Some kind of assets have been excluded. So these are the notable features of these of this legislation, right? European Parliament's legislation. What is more important for us is Indian legislation. So what has happened in India is in 2022 there was a 30% tax on income earned from these transfer of virtual assets, right? There was a 30% tax. In 2023 it was brought under the provisions of Prevention of Money Laundering Act, because you know that these virtual digital assets, they are prone to money laundering. Money laundering, I hope you understand, turning black money into white money using different kinds of ways, you know, different kinds of channels. You put the black money into a system in so many different kinds of ways and for so many times that it turns actually white in the end, right? So it becomes indistinguishable from the white money, you can say, right? So that is the meaning of money laundering, and virtual digital assets were brought under the provision of Prevention of Money Laundering Act in 2023. And in G20 there was the declaration in 2023 which was called the New Delhi Leaders Declaration. It has emphasized the need for effective regulation of crypto assets, right? So these are the developments in India. You can keep a tab on whatever is happening in this field, because these are areas where you will continuously come up on some kind of new regulations, some kind of new declarations, right? So please keep a tab on that, because government is also thinking on bringing out a policy of on regulating these, and they are also moving in that direction, right? So that's all about crypto assets. Then let's come to National Quantum Mission. So what's National Quantum Mission? It is what is it doing? Obviously, if it is there to scale up the quantum technologies, right? So quantum technology. So if you don't understand the basics of what is quantum, I'll just briefly go over it. So what happens in the usual state is that in the usual binary state of things, right, all computers work in the binary systems. They are which are either 0 or 1, right? So these are bits, right? These are bits, either 0 or 1. Only one value can be there at one point at one point of time. At one point of time, either you can say 0 or 1, right? But in quantum, what you have is qubits, which means 0 and 1 simultaneously are there. Two positions can exist simultaneously, right? That is the meaning of quantum state. Quantum state means that you cannot predict. You cannot say at a particular instant that whether something is 0 or 1, right? It can be both, right? So that is called a superposition, quantum superposition. So in qubits, you can understand, for quantum computers, you can understand that the more qubits you have, the better the better it is for your computer. Maybe it is more fast, right? So in National Quantum Mission, we are talking about developing these kind of quantum computers. We are talking about even other kinds of technologies like cryptography, quantum key cryptography. So what they are saying is single photon sources or entangled photon. Entangled means again, for quantum entanglement, just to briefly explain, if there are two you can say if there are two objects, if they are entangled to each other, which means it will mean that they cannot be described independently, which means that if something changes in one, then it will also change in the other, right? Maybe in the opposite direction. So this is what is called as quantum entanglement, which means that you cannot describe one object without describing the other. They cannot be described independently, right? So they are entangled in a quantum state. So these kind of concepts, they are used for quantum cryptography, right? So you look at this word quantum communications, they can be used for quantum key cryptography, all right, and they can be used for other kinds of applications. So in National Quantum Mission, we are trying to develop these kind of technologies. We are also saying that we want to develop high precision clocks, magnetometers, right, and some kind of materials like superconductors, some semiconductor structures. Okay, so we want to develop some kind of quantum materials of this kind, right? So these are the points under the mission, right? So you can see the cost, 6,000 crore is a huge amount which is dedicated to this mission. It will run for more than 6-7 years, and it is being implemented by the Department of Science and Technology. It is in partnership with the other departments, right? So that's all about quantum mission. Then we can move to the next thing, which is BharOS. Now this is a mobile operating system, just like your Android or iOS. It is a operating system for your mobile, but it's called BharOS because it is made indigenously in India by people at IIT Madras. So it is developed by J&K Operations Private Limited at IIT Madras incubated company, and it is highly secure with features like Nota and Pass. So what means this? Nota means automatic updates to any kind of security updates are there in the app. In the operating system, any kinds of security updates are there, it will automatically update. And vetted apps means that it will examine whatever apps if you want to download, right? It will there is an infrastructure in place to examine these apps and test their security. If they are very safe, if they are very secure, only then can you download it, right? So it comes with a lot of safety features, security features. That is why it is said to be highly secure. This operating system is said to be highly secure, and it has no default apps. Like if you buy Android or iOS, you will always find some default apps in your phones, right? But with BharOS, that is not the case, right? So that is why it is you can say it is better in comparison to Android and iOS. All right, so that's all about BharOS. Okay, so moving on, next is the remaining few topics. These are some of these are nuclear technology like small modular reactors. Some are miscellaneous topics, vanadium and Samudrayan. And after that we will do the Nobel Prizes also, as I had told you in the beginning. So these are the remaining topics. Let's go with vanadium first. What is vanadium? It is one of the 30 critical minerals which is identified by India, which means that it is quite an important metal, right? Why is it important? Because it is crucial in defense, nuclear reactors and aerospace. It has applications on all these things. Even iron and steel industry, it is used as an alloying element, right? It is used in batteries also. What is the news regarding it? It is actually rare to find it naturally, but we have found some samples of it from Gujarat, from the Gulf of Khambat, okay, off the coast of Gulf of Khambat. We have found this hard silvery grey metal in some sediment samples have been analyzed, and vanadium is said to be present. Okay, earlier it was found in Arunachal Pradesh. In India, it was initially found in Arunachal Pradesh, and then now we have found it in Gujarat as well, right? So these are just some of the basic things about vanadium. It is atomic number is 23 and the symbol is V. Okay, so that's about vanadium. Then let's come to small modular reactors. Now here these things, small modular reactors, they are actually quite you can say I'd call them revolutionary, because if they become the norm, then they are going to truly transform the industry of nuclear power. Or you can say they can even start a new kind of an industry. So what are we talking about? We are talking about small modular reactors. Small means definitely they are smaller in size than the large scale. Large scale reactors will develop power around 300 megawatt to 1000 megawatt. But small modular reactors, they develop power in the range of 20 to 300 megawatts, right? So they are small in that sense, right? They do not produce much power. Modular means that they can be produced in a factory. So right now, when you go and install nuclear power plant somewhere, you have to go and build it in that area, right? You have to go and build it in that particular location. But small modular reactors, they can be produced in a factory, right? And they can be produced easily, even by private companies, right? So that is the advantage. Then reactors, obviously, it is going to do nuclear fission reactions, right? Not nuclear fusion. Remember, it is nuclear fission reactions, right? So the advantage of these kind of reactors is that once you install one at a place, right, later on, if you want to increase the capacity, you can add more, right? You can keep on adding more if you want, so that you can increase the capacity of the reactor. It can produce more power in that sense, right? Then the thing is, why are they not in so much of popular use, right? So the technology is still being developed, and you can see that the China has launched world's fourth generation nuclear reactor, and it is using small modular reactor design for that fourth generation reactor, right? So in a fourth generation reactor, you use gas as a cooling agent. You use gas, which is helium, for cooling, unlike in conventional power plants. You know that you use pressurized water. So that is the meaning of fourth generation power plant. But the important thing is that they are using small modular reactors, right? So these small modular reactors, they are small, they are scalable, and they are factory assembled, right? Scalable, as I told you, you can add more and more of these modules, and you can increase the power output. Then they can be made in factories. They are economical, and they are also safer, right? So if such a technology is permitted tomorrow, then you want to mass produce it, then you might want to involve private entities. So there might be issues of like okay, how can you give nuclear permission to make nuclear power to the private companies, because it is currently in India it is the sole prerogative of the government. You cannot only the government can produce nuclear power, not the private entities, right? But maybe in the future you might have such kind of projects, because see, the big thing that will happen because of these is that you can decarbonize your energy sector, right? Because nuclear energy, after all, is clean. It is not producing any greenhouse gas emissions. So you can decarbonize your entire energy sector if you are permitting these small modular reactors in the future, because you can install them in more places, in places where you previously could not install wind or solar or any other kind of renewable energy. Now you have an option of small modular reactors. So that is why it is important, because see, there are some if I talk about some small townships, like Bhel will have some townships, or IFCO will have some townships. So right, so if you install a small modular reactor at one corner of this township, you can power the whole township, and it will be a clean way of powering the small town. So if you can apply it for these kind of situations, you can definitely help in reducing carbon emissions. So that is why this is important, and in the future we might see moving in that direction, where small modular reactors are going to be the ways in which we are using nuclear fission to generate energy instead of the large plants that you have, right? So that's about the small modular reactors. Let's move on to Samudrayaan. Now Samudrayaan, you know that India has space missions, all kind of space missions to Moon and Mars and to Sun. But India also has a deep sea ocean mission, and deep sea ocean mission is called the Samudrayaan. Okay, so Samudrayaan, it will be India's crewed expedition to a depth of 6,000 meters, right? And the name of this submersible is Matsya 6000. Okay, the name is Matsya 6000, and it is implemented by the Ministry of Earth Sciences, right? So the New India 2030 document, it outlines a blue economy as the sixth core objective for India's growth. So blue economy is related to oceans, like oceans, rivers, or everything that is related to water. So basically, most of the times it is related to marine economy, right? So here the Samudrayaan is going to contribute to the blue economy. How? Why are you sending this mission? There are definitely, one thing that you can do is you can go and see what is there in the deep ocean. Okay, you can see, okay, what is there in the deep sea. There is what kind of animals are there. What can I go and explore. You can see the right types of rocks. But some things that you already know, that there are polymetallic nodules over there. So polymetallic nodules, what are these? Poly means many, metal means metallic means metals. Nodules means these are just small kinds of these kind of rocks, very small. They are flattened. Okay, they are flattened also, and they have several metals. Okay, they have these important rare earth metals. Okay, these polymetallic nodules, they have these rare earth metals, which if you can extract them, you can use them for your electronics industry, right? This is the connection with blue economy. So the thing is, they are going to look for these polymetallic nodules from the central Indian Ocean, where they are said to be in vast quantities. They are going to mine these, right? Secondly, they are also going to study the ocean climate or you can say the changes in ocean temperature, salinity, all those things, so that you can understand the climate change which is happening due to oceans. Or you can say the phenomena associated with oceans, right? Ocean temperature, ocean salinity, all these, how are they related to climate change? You can study these and you can form some kind of future plans, right? You can predict some kind of event, so you can understand something in great detail, right? So all these things you can do. Apart from that, definitely you will be exploring the biodiversity that is there on the ocean floor, right? And it is also said that they are also trying to understand how to extract fresh water, right? So there are several objectives to this mission, Samudrayan mission, right? So that is how it is linked to blue economy. And if you look at this decade 21 to 2030, it has been designated by the United Nations as the decade of ocean science, right? So this is also something that you can keep in mind. So that is all about Samudrayan mission. Remember that it is a crewed mission, so they will be taking 3 members, okay, 3 crew members who will be going to deep seas to a depth of around 6,000 meters, and the name of the vessel is Matsya 6000. This is the name of the vessel. All right, so let's move on to Nobel Prizes. Of course, there are physics, chemistry, and medicine that are of interest to us. There are Nobel Prizes for literature, economy, and okay. All right, so we will look at physics, chemistry, and medicine, and let's start with physics first. So here you can see that the names, usually the names are not important for us in the UPSC exam. But remember, like, what is the concept? Like, what is something that they have discovered? So here, what happened in physics? What is something that they have discovered is that they have actually. Let me explain it in a bit more simple manner. Let's imagine that there is an object which is moving very fast, and you want to take a picture of it, right? You want to take a picture of it, so you have to send a light wave which is very fast, right? And it can, because this object is continuously moving, you have to take a picture when it comes to your camera is over here, and you have to take the picture when the object comes at this place, right? Otherwise it will go away, right? So you have to send a light beam that can quickly take a picture, and it can show you what it has captured, right? So this fast object in this case is electron, which is moving very fast, right? And for measuring, clicking a picture, you need pulses, light pulses, which are measured in attoseconds, which is very, very small. To give you a scale of it, 1 attosecond is to 1 second as 1 second is to the age of the universe. Imagine. So 1 second compared to the age of universe, that is how 1 attosecond compares to 1 second. So it is a very, very small unit of measuring time, attosecond. And attosecond pulses have been used to detect the motion of electrons. So electrons move or change energy rapidly in the magnitude of attoseconds, which makes them very difficult to study, right? And you can see that the relation that I have given to you. Then the 3 physicists, what they did was they created attosecond light pulses by shining laser light through a gas, making it possible to study such rapid movements, right? So you can read about the process over here. What happens when laser light is transmitted through a gas? Ultraviolet overtones arise, and under right conditions, when their cycles coincide, they form concentrated attosecond pulses. The whole detailed explanation is not as important, but you can just read it for your own curiosity. You can read about the applications. This is definitely important. These attosecond pulses, what can they be used for? They can be used for measuring the movement of electrons, rapidly transforming insulators into conductors, and identifying molecules such as in medical diagnostics. So these are the different applications, and this is why they have been awarded the Nobel Prize for the exploration of electron inside atoms and molecules, right, using attosecond pulses. All right, so let's move on to the next one, which is Nobel Prize in Chemistry. So in chemistry, they have been awarded for the discovery and synthesis of quantum dots. Now, quantum dots are nanoparticles. Okay, they are nanoparticles, which means they are the You know the range of nano size, 1 nanometer to 100 nanometers, right? These are nanoparticles, and so obviously they are very small. They are the size of a few thousand atoms, all right, and they have been manipulated by the scientists. When you manipulate them, you can get different colors, right? So if they are big in size, they are red in color. If they are small in size, they are blue in color, right? And all these quantum dots, they have applications in your TV screens, in your imaging, in your illumination, right, in your production of photons, right, in your solar cells. So all of these things are the places where you can utilize these small quantum dots of the nano size, right? So what happens is that we're going, obviously if you know about nanotechnology, then thing about nanotechnology is because things are reduced to such a small size, they exhibit different kinds of properties, like they deviate from the usual properties and they have some other kind of properties because of the quantum effects. We've already seen what is quantum physics. I've explained it to you, but in nanophysics also, in nano materials also, quantum effects dominate Newtonian effects. To put it very simply, quantum mechanics will dominate the Newtonian mechanics which is there around us. So at that scale, you can say the physics changes a little bit. So because the physics changes a little bit, so the properties of the substances also change a little bit. That is why quantum dots exhibit these kind of different kinds of properties, and they have applications in all different kinds of fields. Let's move to the next prize, which is medicine, right? So in medicine, they've got a prize for making mRNA vaccines. Now, what are these mRNA vaccines? It's very simple, nothing to worry about. If you know how RNA works, how protein is formed in the body, then you will easily understand what is mRNA vaccines, right? So what happens here? We can take the example of COVID-19, because mRNA vaccines were prominent in the COVID-19 pandemic also. So what happens is that you make a messenger RNA, right? This is your coronavirus, right? And these are your spike proteins, right? These are your spike proteins. So what you do is you take the gene, or you take the RNA which is responsible for this spike protein, right? You take the RNA strand which is responsible for this spike protein from the virus, right? This is called as mRNA or messenger RNA. Right? Then you send it into the human body. Okay. Then you send it into the human body. Now, human body, what will happen is it will go inside the nucleus of the cell in the human body, and it will start producing the protein associated with it, the spike protein associated with this RNA, which comes from the coronavirus, right? The spike protein of coronavirus will be produced in the human body now. Okay. Now, when the spike protein is produced, the immune cells will come and start killing these spike proteins, right? So your memory B cells and memory T cells will be activated, and now they will remember the spike protein. So the next time you get the actual infection, you will have the memory immune cells, which will easily combat the COVID-19 virus, right? So this is how it happens. You take a small section of the virus's genetic material, the instructions or blueprint for a specific protein, like the spike protein that I told you about, right? What you do you actually package it also in a capsule. These are nano capsules, very small sized capsules, right? So you put it in this capsule, like you can see the RNA strand is put like this, right? Then your body will make this protein. When you put this nano capsule in the body, your cells will start making this protein, right? And it will build immunity against any invaders, because this protein, the spike protein, will be displayed on the cells, and now your immune cells will come and attack these proteins, right? They will come and attack these proteins. So they will your body will develop immunity against COVID-19 because you have identified the blueprint for COVID-19, which is the spike protein, right? You have identified that, your body has identified that. So the next time actual virus comes in, your body is already ready. It has the memory cells, memory immune cells to fight the virus. So this is the principle of mRNA vaccines, right? These are very efficient vaccines. These are very simple to make, very easy to make. You just need the DNA or RNA from the virus, and they are very cheap. They are cheaper and they are cost efficient, and they are easily made. They are very fast. Faster in terms of the whole process. So that is why they are better than the traditional vaccines, which are maybe the live attenuated vaccines or the inactivated virus vaccines. So all the different kinds of vaccines are not as good as the mRNA vaccines, right? So we saw that in the COVID-19 pandemic. Even the data showed us the same thing, right? So that's all about the current affairs for the prelims. All the best for your exam, and I hope that this session proves to be of some help to you in the concepts in both your prelims and mains exam. And keep learning, keep looking at the news items. There's many things that we have not been able to cover because of the time constraints, but this session was just to give you an idea about what kind of topics are important, what kind of things you need to look at, and how to focus on understanding of the issues and concepts surrounding the news items, right? So thank you so much, and all the best to all of you.